Hello all, my name is Brian Brazel, so I thought I'd tell you who I am first because I've got you for the next 30 minutes. So I am an engineer who cares about production. I'm one of the Prometheus core developers along with Julius, Fabian and Bjorn. I run Robust Perception, the world's only company providing consulting and support around Prometheus. Previously, I worked at Google for 7 years and did a fair bit of monitoring, not as my primary job, but in order for me to be effective, I need good monitoring and good metrics in order to figure out where to look at with my logs, my profiling, and my code searches. And I've also been doing open source stuff for probably 15 years. So, I get lots of questions talking to all of you about what Prometheus is. At its core, Prometheus is a time series database. And we use it for white box monitoring. That's looking inside your application from information your application is collecting. And we make trade-offs for operational monitoring. It has two things that make it really powerful. The first is it has labels, which some systems call labels, dimensions or tags. So those are key value pairs associated with everything. It also has an extremely powerful query language, which lets you take advantage of those key value pairs, slicing and dicing any way you want, and graphing and alerting both use the same language. So if you can graph it, you can alert on it. So to look at some of the history, Prometheus is inspired by Google's Borgmon monitoring system, which I think was talked about last year on this very stage. It was started in 2012 by some ex-Googlers working in SoundCloud. To be clear, I never worked in SoundCloud, because that's a common confusion. It's primarily written in Go, which was a good choice. We publicly launched about 1.5 years ago, and we're just prepping to launch our 1.0 as well in the next few weeks. It's independent of any one company, and we're currently incubating with the Cloud Native Computing Foundation to give us long-term governance. It's a very, very healthy open source project. As of January, it had 250 people contributing. So that means we've got an extra, 20 contributors a month. And even just this morning, as I was, fretting for this talk, I noticed, hey, someone filed a bug report. And 40 minutes later, by the way, here's the pull request to fix it, which is awesome. That's awesome to want. There's also a whole pile of third-party integrations. And to give you an idea of how easy those are to write, most of them were created without the core team ever knowing about it. And there's also hundreds of companies using it. It's always hard to estimate how many people are using an open source project because it's an open source project. But I do know that I think 5 sponsors of this conference are using Prometheus, as far as I know. So I want to kind of look a bit at the architecture of Prometheus to give you an idea of how it works. So Prometheus is a pull-based system. No booing, that's a good sign. So the problem with pull is, okay, how do you find everything? Which is a valid question. Because with push, it kind of just works, right? You just need to find what to push to. So what we have is service discovery. We will go out, we'll talk to EC2, we'll talk to Azure. GCE, someone sent the pull request on Monday, we're still reviewing that one. We can talk to Marathon, we can talk to Kubernetes. We've got 2 different ways of pulling data from Zookeeper. We can talk to Console, get that information, and figure out where all your machines, where all your applications are. And if you don't have those, we'll do JSON as well. And then we might say, hey, we've got some C advisors. If you've got Docker instances, which you probably do, C advisor will give you all the C group stats. It directly exports Prometheus metrics, so great, we just go and grab them. Perfect. Cassandra, something a little different. Cassandra does not expose Prometheus metrics. Someone's actually working on that. Anyway, but it does support JMX. So we use a JMX exporter to get all those, pull out all those nice labels. We go scrape that. You might also have some batch jobs. Now, batch jobs have a little problem with pull because it's kind of difficult to pull from a job that no longer exists. We don't have time travel. So what we do there is we've got a binary called the push gateway. So at the end of the job, it'll say, hey, I'm done. I succeeded it. I took this long, processed this many records. It'll cache the last run. Prometheus goes scrapes it. So all this data is coming in from all these systems, different systems. Some of them support Prometheus directly. Otherwise, other places we've got exporters to deal with it. And that's all coming in, all being buffered, all being written out to SSD on the local machine. Then we apply the rules and the alerts. These are Prometheus expressions. Some systems call these standing rules or persistent queries. And alerts are just a form of those that happen to send on to the alert manager. So all these Prometheus servers are sending to the alert manager. It then talks to PagerDuty, Slack, HipChat, email, and we can chuck JSON into the void if you want to as well. Then the final part is how do you get data out because I like pretty pictures. The answer is we have a HTTP JSON API, and Grafana is what we recommend. All the dashboarding solutions out there, you can write your own. They all use the exact same HTTP API, which is all nice and public. So that's roughly how Prometheus works. Because the thing is, as well, we're kind of looking at things that already exist. And it's nice to monitor your existing infrastructure. But we kind of want to monitor your applications as well and your business logic. If you think of your microservice architecture, right? It's kind of a tree, hopefully acyclic, right? And for each of those components, you're going to monitor your request rate, your errors, and your latency, right? Those are the 3 basic stats for an online serving system. But if you look at one of those microservices, internally, it's going to have a fractal state. It's going to have some libraries, some subsystems that are also talking to each other in a tree, which is hopefully acyclic. And you should monitor those in the same way. And the principle of Prometheus is that each of these libraries is instrumented, and then Prometheus kind of comes and grabs that on a regular basis and gives you those level of insights into your application. And to do that, we have client libraries, just like most other things. Ours are a little different in that our client libraries aren't just about marshalling data, because we have our own custom data format. They also take care of all the bookkeeping. They care of the current currency, and we try to make it as easy as possible for you to use them. So this here is a complete example. First off, you can install it via pip. So this is a Python example. Then we can create a metric. Here, request duration seconds. It's a summary. And there's a help string as well to help you remember what it was. Because when you start having thousands of these, you will forget. And you can call it directly, request duration.observe, 7. It took 7 seconds. Or you can use a decorator here in Python to just say, hey, this function, automatically take care of it for me. And that takes care of exceptions and all the nitty-gritty for you, making it as easy as possible for you to use. You put your code here. Obviously, this isn't going to do much because that's saying do nothing, and a HTTP server. Now, some of you are looking at this now and saying, wait a second, seconds? Are you telling me Prometheus can only handle seconds? The answer is no. Prometheus has full 64-bit floats. And so it means we can use seconds here. Because some systems only do integers, which means that you, as the person instrumenting the code, has to choose the unit. Do you choose seconds? Do you choose milliseconds, nanoseconds, microseconds, picoseconds? And sometimes you're just trying to control what's going to end up on the other end in your Grafana and your dashboards. And I say that's silly. If you're instrumenting, you shouldn't care what the unit is. In the same way that you wouldn't store a time zone into a database. You store Unix time, right? And leave the time zone to the presentation layer, your dashboard layer. It's the same with Prometheus. Hey, let's use base units like seconds because we're using floats. It works. The other thing is, wait a second, that's a 64-bit float. That is less precision than a 64-bit integer. Isn't that going to be a problem? So a 64-bit integer has 53-bit mantissa. That's the precision part. 53 bits, it turns out, let's say you had some metric, but you were incrementing 1,000,000 times a second, which is pretty fast. How long? Well, there's reasons why you use that. No, it's 1,000,000 times. That's going to cover you pretty nicely. How long until it overflows? So you can do the math, and it works out as 274 years. So we do have to advise everyone, please restart your servers at least once a century. The other thing, as well, is that, if you're writing some application code, it's kind of annoying that someone says, oh, use this instrumentation, that library, that one, oh, I've got this monitoring system. Prometheus is an open ecosystem, okay? We take open source seriously. So yeah, you can go and expose over HTTP and it all works nicely with Prometheus. But it's also 2 lines of code to push out the graphite, because that API is there, and I think that's only 20 lines of code in the back end. So if you want to push out to any other monitoring system you already have, you can do that. That means that you as a library author or as an application developer who's giving code to other people can say, look, we've instrumented with Prometheus, you can use it whatever you want, just add 2-3 lines of code. And that's pretty neat. In fact, in Java, it's fewer lines of code to export to Graphite than it is to Prometheus. Yeah, because I can control the Graphite API because I'm writing it, whereas servlets. The other thing is, though, that goes the other way. Because Prometheus clients can also parse the Prometheus data format. And we've got a whole pile of exporters which can take data in, whether it be InfluxDB, CollectD, StatsD, CloudWatch, JMX, SNMP, there's a few others, Graphite, and produce it into Prometheus data format, which gives us some interesting options. So sure, you could have Prometheus going great to CAdvisor. But maybe you want to send CAdvisor to Graphite, which it kind of already supports. You could have a little bit of Python in the middle. Or another example, there is a monitoring system called Zmon, which is produced by Zalando, which is a German clothing company. Think of it as a distributed Python Nagios. And they actually do this. They run the node exporter, which is Prometheus' machine agent. They're not running Prometheus in this part of their system, but it's going scraping the node exporter, grabbing some stats, and doing checks based on that. So they've been able to take advantage of the fact that we've figured out how to parse /proc and being able to reuse our work. And that's awesome. Let's do more of this thing. Another example you might have is, let's say someone's written an application that only exports to InfluxDB. The good news is InfluxDB's data model is pretty similar to Prometheus's. So you can run an InfluxDB exporter. You could have a little bit of Python going scraping that and push it out to, say, hosted Graphite. So you can use Prometheus as a clearinghouse to take care of all your metrics, and hopefully we can kind of start standardizing. Because it frustrates me as a monitoring system author that every single one of us has to reinvent the wheel. Every one of us has to figure out, how do I get data from Cassandra, from MySQL, from Postgres, from everything. This is silly. Let's see if we can just reuse each other's work. That'd be kind of nice. Of course, labels are where things are really nice. Because if you're used to Graphite, you're used to dotted strings. Metric, Monitorama, Portland. And that's great, until someone puts a dot in there and all your globs break. Escaping, people, escaping. But Prometheus, it's all key value pairs, and those are unordered. So we can cut and slice whatever we want. In fact, the values are full UTF-8. We have seen the Unicode Snowman, someone did it. But then you can slice, dice, aggregate any way you want. So here's an example of some of the power. Let's say you've got a whole pile of Docker images, your company's really gone all in on that, and you'd like to save some CPU. So you want to know, across my entire fleet, what Docker images are using the most CPU, so you can know where to focus your efforts. So here's an example of how to do that. So here we've got container CPU usage seconds total, which is one of the metrics CAdvisor puts out. We use rate on that to basically say, hey, what's the per second value? Add them up by Docker image, so we're ignoring all other factors. We're ignoring the environment, the data center, the instance, the machine, everything else. Add them all up and give me the top 5. So now you know where to focus that optimization effort. And that's kind of nice. That's just a small taste of the sort of analytics you can do in analysis. It's also really good for alerting. Let's say that you want to alert when machines being down. Now, one of the little things about pull, people ask, hey, how do we tell when something's not turned on? Do we ping it or something? The answer in Prometheus is we have a time series called up. If a scrape succeeds, it's 1. If a scrape fails, it's 0. Pretty simple. So all we need to do to test an instance being down is go, hey, if up is 0, alert. And the thing is, if you look at this alert, it's saying up with a job equals node, we're looking at the node exporter, but it's got no other labels. So that means as service discovery discovers new instances, this alert automatically works for them. There is no effort, no code changes required. As instances appear and disappear, this alert automatically works. But we can be smarter than this, because we shouldn't care about a single machine being down, right? Maybe we care about, well, all hell's broken loose, and a quarter of machines have broken down. At which point you probably have a busy pager. We can take the average of all those 1s and 0s and say, hey, if it's less than 0.75, that means, that a quarter of our machines are down, and we get one single alert about something that's definitely a problem, and go look at that. And you can combine these and composite these any way you like. Because Prometheus is not just about monitoring machines. Prometheus actually has no notion of a machine. All it has is key value pairs with the labels. Because you should be looking at services. You don't care if one machine is slow, as long as the experience you're providing to your user is in line with your SLAs. And you can do that with aggregation. Prometheus as well, because once people start using labels, they don't stop. So you kind of need to be really efficient. So let me give you an idea of just how efficient Prometheus is, because Bjorn, who's done a lot of work here, there's talks at GopherCon and so on, which are awesome, you should go check them out, has gotten it to the point where a single Prometheus server can handle 800,000 samples per second. And this is Prometheus, so we're doing lots of in-memory stuff in the clients. So that's not 800,000 events, that's 800,000 samples. To put that in perspective, the node exporter, our machine agent, produces 700-ish time series because we troll /proc. The exact number depends on how many CPUs, network cards, file systems, and disks you have. But let's say 700-ish is a kind of a typical number for a moderate machine. And let's say you were scraping that once every 10 seconds. A single Prometheus server is capable of handling all those metrics for 11, 12,000 machines, which is kind of impressive. And considering that you'd normally run one Prometheus per data center just to keep your failure domains not mixed up, that means you only need one Prometheus, which means you don't really have to worry about scaling because it can deal with it. The other thing as well is that we have our new var weight encoding, which is based on Facebook's Gorilla paper, which is pretty awesome. And we've gotten it down in production to 1.3 bytes per sample. Facebook reported 1.4 bytes per sample, so it might just be noise and different data, but we're pretty pleased with that. It's also Bjorn's work. Prometheus is also decentralized because pull-based has one advantage of pull is that, well, if I want to test something out on a push-based system, I'd need to go and reconfigure the entire fleet to also push over to my new system where I'm playing around. With a pull-based system, well, I just start up Prometheus on my workstation and play around. It works. Which also means you're a bit safer against rogue systems. I think we've all done it, where we accidentally interfered with production because we were testing something on our workstation. Yeah, we've done it. So it pulls a little safer from that standpoint. But we can take this a step further. We can't just run a Prometheus on our workstation just for testing. What happens if we give each team their own Prometheus? Rather than having to go to a central operations team and say, you know, would you mind hooking these up, please? Each team controls their destiny, is empowered to do what they want. So if you're doing DevOps, whatever that is, then each of your microservice teams, you know, once you've completed all the buzzwords, can go and do what they want with their Prometheus, whatever makes sense for them. So let's take an example. You have a node exporter, you've got some machine somewhere in EC2, and we're grabbing a whole pile of metadata from EC2. The infrastructure team, they're thinking EU West 1, and this is availability zone A. This is the way we think of the world. Now normally, in a company, you've got one central monitoring system. The infrastructure team wins. They decide what the taxonomy is. But with Prometheus, it's not that way. Whoever runs the Prometheus decides the taxonomy. So some other team was like, I have no idea what EU West 1 is, but I know what Ireland is, because that's where EU West 1 is, and this is our production environment. And they're scraping the exact same node the same way. Maybe someone else is doing horizontal monitoring. They want to look across the entire fleet and look at some weird network stats. It turns out Linux puts out about 200 weird network stats, which you can normally get via netstat-s. And they just want to look across the entire fleet. They don't care about any of these notions or whatnot because they're trying to track down a kernel bug. And you could use the same idea for any application level things, looking across the fleet for a library in order to make business decisions and engineering decisions. So you have this power where you can empower everyone and choose the taxonomy that makes sense for each team. Prometheus is also reliable. Now, on one hand, you don't need your monitoring system to be more reliable than what you're monitoring. If you're monitoring a system that only needs 2 nines of reliability, a 6 nines reliable monitoring system is probably more work than it's worth. But you also want a monitoring system that works when your network's falling apart in an emergency. You want something you can rely on as your first port of call. And that's what we want Prometheus to be. Prometheus has no external dependencies at all. It needs local disk, preferably SSD, and it needs to be able to talk to whatever it's trying to get to. And that's it. And this is interesting because there's lots of systems out there that depend on Kafka, Zookeeper, Cassandra, Hadoop. And that's all well and good until the shit hits the fan. And all those CP systems that are doing consensus fall apart. Whereas Prometheus, well, it's a single server. It just keeps on going because it's not trying to do these very difficult distributed systems problems. And for high availability, we also keep it simple. Our way of doing high availability for Prometheus is you run 2 identical Prometheus servers, both doing duplicate scraping, both sending alerts. And our alert manager will take in those alerts and deduplicate them. Nice, simple, obviously reliable, because there's no complex clustering in there that takes years to get right. And we can go a step further. Because everything's going through a central alert manager system, we can group alerts. So maybe you don't want to get one notification for every single machine. Maybe you say, no, aggregate them by data center. So you receive one notification about every machine that's having a particular problem. Or maybe you want to go the other direction. Maybe you've got a propagation delay alert, which, is caused by the root. So it's happening across all your clusters. So you decide to aggregate that one by alert name. Once again, you're now getting one notification instead of one per data center. And this is getting closer to the ideal of one notification per incident, because you want to keep your signal-to-noise ratio good. And we are as well working on making the alert manager HA, Fabian's working on that, and we're using eventual consistency for that to make sure it stays reliable and simple, because eventual consistency is easier to get right than consensus. As a project as well, we are opinionated, and not just about pull. We try to avoid reinventing the wheel, because we know we are limited in our time. There are many, many yaks we could shave, and we've decided not to shave. So one example we have is PromDash, which is a Ruby on Rails dashboarding system. It's very similar to Grafana. And maybe about 9 months ago, someone added a plugin to Grafana, which ultimately ended up being a first-class support for Grafana for Prometheus. And we went, you know what? We have to keep maintaining PromDash. Or we could use Grafana. Let's use Grafana. So PromDash is now deprecated, and we recommend everyone to go use Grafana, which I'm sure you can learn about more in the next talk. And there's a few other places like that where you've said, we're going to avoid scope creep. We're just going to try and focus on what we do really, really well. We also try and encourage best practices. Okay? If someone comes to us and say, can you do X with Prometheus? And we'll go, you should use this solution instead. So one example we've seen a few times in the last few weeks is someone wants Prometheus to restart their servers automatically when they die. Okay, so you'd have a node exporter going to Prometheus, going to Alert Manager, sending a parameterized JSON request to a script executor, which will restart your process. And that'll all work, that's all supported. I implemented some of that stuff myself. Great. Or you could use a supervisor. Use systemd, use daemon tools or whatnot. Use Monit. So we'll kind of try to point you in the right direction because we want people to use the best tool for the job. If it's not Prometheus, we'll tell you that. So we have the live demo now. Let's hope it works. Pray to the demo gods. So this is on demo.robustperception.io. So here's an example of actual Prometheus metrics. So you can see here, the labels is just brackets. This is our text format. And here, for example, is the CPU stats. So you can see it's broken out by CPU and mode. This is only a one-core box, so it's not very interesting. But you notice these numbers seem to be a little on the big side, because Prometheus uses counters, which kind of go like that. Up and to the right is good, but I don't want to be trying to figure out the angle that's going at, because that's the total CPU used since the process started. So what we can do is use the rate function to convert that back, stack it, and hey, I can see this system is using about half its CPU. So that's a very, very simple expression with Prometheus. And we've got Grafana as well. There we go. Full integration there. And you can take advantage of labels and Grafana templating to automatically pick up all your machines. So that host name is not hard-coded anywhere inside our Grafana configs. It's being picked up dynamically. Of course, it's not very interesting because this Prometheus is just monitoring itself and the rest of the machine. Here's the alert manager. I've got just a sample alert here, but you can also silence alerts. So if you know maintenance is coming up, put in a silence based on labels again. So you say this entire data center, no alerts for the next 2 hours. Because once again, you don't want to be paged unless there's an actual problem. I'd also like to show you a little something I'm proud of. I may horrify you, and let's hope we've got internet. Yes. Using the latest in web technology, HTTP meta refresh. So this depends on the Wi-Fi. Now, for those of you who have, oh, is that lighter? Is it? No, it is not. I've been waiting to see it lighter. For those of you who haven't studied computer science, Conway's life has been demonstrated to be Turing complete many years ago. You can build a Turing machine in it. That means if it's possible to compute it, it's possible to compute it with Conway's life. And because I've implemented Conway's life in Prometheus using the query language, that means the PromQL, our language, is Turing complete. Yeah. Which means it's just as powerful as Ruby or Java or Go or even Haskell, Don't do this in production. Please don't do this in production. But it's just an example of just the sort of thing you can think about doing. And in case you're wondering, yes, here's the expressions for that. This is likely the most complicated thing that has ever been written in Prometheus, and hopefully it'll stay that way. One thing we aren't good at doing is random number generators, which is why we're just using time, and it mostly works. Cool. Okay. Cool. Oh, come on, yeah. There we go. So just to kind of summarize, what defines Prometheus? Prometheus is open source. We're an open ecosystem. We want to help everyone. We make our instrumentation easy, and you can use your instrumentation without using the rest of Prometheus. You can benefit from it. It's powerful due to the labels, due to the query languages take advantage of those labels. It is extremely efficient because one machine can plausibly monitor 12,000. It is decentralized, empowering each team to do what they want and not having to talk to a central ops team to manage their monitoring. It's designed for reliability, so it can be the first thing you go to in an emergency. And it is opinionated because we want to do one thing and we want to do it very well. And we want to help you succeed. So here are some resources. The main website is prometheus.io. We've got a Google Groups list. We mostly hang out in IRC on Freenode, #Prometheus. The demo I just showed you is demo robust perception.io. My blog's there. Once a week, some blog on Prometheus. If you're using Prometheus, you should be doing that. And queries there. So are there any questions in however much time I have left? Oh, 5 minutes for questions. Any questions? Let's see a hand. Yeah, up there.
How would one go about trying to transition from a graphite-based binary push to Prometheus full assertion?
Okay. Okay, so the question is, how would you transition from a graphite-based push to a Prometheus-based pull? So as a first order step, just to try things out, because you want to try things out before fully committing, no, it's just good engineering practice. It might be awesome, but still, that doesn't mean you can throw caution to the winds. We have a binary called the graphite exporter, which can take in graphite stuff, only the text format, not the pickle one, and convert it into Prometheus metrics. So that's good for getting you started. Ultimately, what you want to do is instrument all your binaries with our client libraries. But even then, like a good place in general to start is the node exporter, or the MySQL exporter, or the JMX exporter for Cassandra. You take existing infrastructure and you monitor that. Because to be honest, going and saying all to your developers, hey, we want to change it to this new instrumentation library, that's a hard sell. It's saying like, yep, we're going to spend the next 2 months converting over to Prometheus instrumentation libraries. Start off simple. Start off with something like the node exporter. We probably give more metrics than every other system in terms of machines because we're basically just trawling all of /proc and /sys and work from there. And over time, get your infrastructure. And then once everyone's used to it, everyone's happy, everyone's committed, then we can start talking about the big stuff and going directly to direct instrumentation and ultimately getting rid of the graphite exporter inside your setup. But we do have things like that for transition, for CollectD, for StatsD, for Graphite, for InfluxDB, all of those, we have them. Cool. Yeah, question there?
Have you guys given any thought to sort of a cookbook for the PromQL?
So the question is, has any thought been given to a cookbook for PromQL? Yes, we're also very busy. So like one of the things like short talk will mention Grafana.net, so there'll be dashboards there and we'll get around adding stuff there. There are some examples, like you can crib some stuff we're doing. The big problem with monitoring, it turns out, isn't so much writing the expressions, because there's only like 5 or 6 common patterns. It's actually knowing what metrics to plug in there. And figuring out the expression is pretty easy. So when you get a dashboard from somewhere, the real thing is, someone's figured out the important metrics. Not, someone has figured out the expression, because there's very few expressions which are particularly complicated. Cool. Any other questions? Anyone?
Can you describe the time series storage?
Sure. The question is, can you describe the time series storage? So we have metadata sitting in LevelDB. And then the time series storage itself is custom, and it's 1 file per time series. Don't worry, you won't run out of inodes. We were initially using, I think it was LevelDB purely, and that didn't scale at all. But now it's basically a file per time series, which is one of the reasons we recommend SSD, and we're just batching out writes to that. Because most queries as well are kind of just want a chunk of time series, so that's efficient to get. And most stuff's going to be coming from memory anyway. So things are basically 1024 byte chunks in memory. I think that's 1050 or something with the header on disk. But there's an FAQ at some point. Bjorn will write a paper about all that.
And is it round robin?
Okay. The question is it round robin? The answer is no. Prometheus stores the raw data with no downsampling. Because, well, A, it's very efficient, and B, we believe that downsampling is the job of long-term storage. Any other questions? Oh, there's a question.
Do you support anything besides strings or label values?
So say that again, please.
Do you support anything besides scalar strings for label values?
Okay.
Collections, for instance.
Okay, the question is, do we support anything other than scalar strings for label values? The answer is no, we support strings. But if you want to do like an array, what you normally want to do is have multiple time series with different values for that label. Which I hope answers your question. Okay.
One question.
Which time? Okay, so we've got one last question. Yep.
One question. So you were saying that you expect, you want to give one Prometheus server per team.
Mm-hmm.
One of the challenges is if people really cared about their service being up, you could like do that, but most of the time, people, like you need external monitoring because people really don't care if their service is being up. So I was just wondering, in this model, like, does giving each team its own server is a good idea in practice?
Okay, so the question is, people might not care about their systems being up, in that, and my suggestion then of giving one Prometheus per team, is that a good idea? The thing here is that you're asking the wrong question there. If your teams don't care about their monitoring individually, you have bigger problems. Because, to be honest, just one Prometheus per team is just one suggested deployment model, because it normally ends up that way organizationally anyway. You could run your Prometheuses for them and have them centrally as well, like that's a good way to start out. But this is really more a social question, which I think was covered a lot in the first day. You can do it whatever way you want, it's just a suggestion. And I think that is it. Yep, good, thank you.